Oh, God bless. You will 100% need a calculator today, so I hope you all have one. You don't necessarily need a graphing calculator, you just really need a calculator. Okay. Did you write down an answer for your bell ringer? Anybody got a definition for it? Huh? It said define it and then give an example. Those are two things. Separate things. Anybody try to write a definition? Correct. An exponent represents how many times you multiply something by itself. So 2 to the second power is really saying 2 times itself twice. Okay. Good. And then literally any example. Literally the example I just said counts. Okay, so chapter 7, we are going all the way in order. We are talking about exponents for the most part. We will talk about a special type of function halfway through, but we'll get there. So to start with, 7.1 is called multiplication property of exponents. There are a few of these. You do have to learn them all. There's a few properties. You don't technically need to know their names, though they'll make sense. You just need to know what they do. Okay? So, the first one is called the product of powers. I'm going to give you the general form of this with no numbers in it, and then I'll give you an example. Okay? Now, the general form, if I have a to the m power multiplied by a to the p power. When we multiply numbers or their variables, we add their exponents. So a to the m times a to the p turns into a to the m plus p, because we don't know what those are. Such that I can give you this example. If I have, and with variables you get parentheses, so x to the 5th power in parentheses. I know that's hard to see. I'll pick a different marker next time. Next set of parentheses, x to the 7th power. Since they have the same base number, they both have x, the x stays the same. When you multiply whole numbers or bases, you add their exponent. So this turns into x to the what? 12th. So this is x to the 12th, and that would be my final answer. Not so bad. First one pretty easy. Okay. Next one is called power of powers. Which is exactly how it sounds. Parentheses, a to the m power, close your parentheses, all of it to the p power. This is how I remember it. P is on the outside of the parentheses, right? When you have a whole number outside of the parentheses, what do you do with it? You distribute and you multiply it. You're going to do the same thing with exponents. You take that p and you're going to multiply it inside. So this turns into a to the mp right now, because we don't know what mp is. So it's m times p. Okay, example. Pretty easy. In parentheses, b to the 5th power, close your parentheses, to the 3rd. What is my final answer going to be, Isaiah? What's my answer going to be? Multiplication. Yeah, b to the 15th. When you distribute, you multiply. Last multiplication property, there's properties of the other kind, but this is just multiplication, is called power of a product all kinds of colors for you today. What this is what happens when there's multiple things in the parentheses. So in the parentheses, we're going to have a to the, I don't know, n power. And what about b, and we'll leave it as b, which is just b to the 1st power. Close your parentheses. All to the m power. Just like the last one, this is just showing you and reminding you that you need to take this m and put it with everybody, and you only multiply it by the things in the exponent spot. So what number is technically in the exponent spot on the b? 1. Right? So a turns into a to the m times n, because we usually do it alphabetical. B turns into b to the m, because 1 times m is just m. You're still multiplying, and these guys still stay in their order they were in. Example, parentheses, -2 x y squared. Close your parentheses. All of that is cubed. Okay, so that 3rd power has to go to the 2 also. So if I had to write this out, just so you saw it, right? So it's -2 to the 3rd. X to the 1st times 1 times 3. Like if you had to see it. Y already had a squared, and you're multiplying it by 3. Again, you don't have to show this step, but for right now, it's just so you can see it. You have to put, everyone forgets these whole numbers. Don't forget the whole numbers. So then -2 to the 3rd power actually turns into what? -8. X is to the what power? And what is y to the? Does anyone remember or know the rules for negatives and powers? A negative number with powers, with even numbers as a power and an odd number as a power? I'm having a hard time. Anybody knows? If you know this rule before I say it, I will give you a bonus point. Well, you don't have your hand raised, young man. Donovan? Correct. No matter what the number is, if you take a power of an even, when the power is even, the answer will always be positive. The power is odd, the answer is negative. You just have to pay attention to where the negative sign is, because that will throw you off. People will get things wrong just because of negative signs. So please make sure you're paying attention to what you are doing. Okay? Okay. Once we have this down, Donovan, come get your sticker for me. I'll flip this board, and we're going to do just a bunch of examples like this. They'll be in any kind of order I want. And you just have to use these power product properties. Okay, I'm actually going to turn this because it's easier. Okay. First example, parentheses, 6 n to the third, close your parentheses. Next set of parentheses, 2n to the seventh. So you still have to use your order of operations. I always look at my whole numbers first. What are your whole numbers doing right now? Being multiplied, so multiply them. Ty, what do I get? Okay, 12, that's easy. My variables are technically also multiplying, right? But what do we do with their exponents? We add them. So Chloe, what's my answer? 12n to the 10th power. Pretty easy. Okay. Bump it up a step. Those are easy. I'll skip a couple and go to this one. How about this guy? Bracket. You have to make a bracket. Parentheses. 2 to the third. Put a parentheses after it. Put a squared on my parentheses. Close my bracket. Put a fourth. That is a problem. It does use one property. One of them. Only one. It uses it multiple times, but it uses it one. It's one of them. What is this property? What are we doing? Or do it and then tell me. I would write the simplified answer and then write the big, scary answer. So what? So what are we doing? What are you doing right now to figure this out? Power. So what are we doing? Yeah, so we're taking 4 and we multiply it by 2, which is, and we take that answer and multiply it by, which is, so that's 2 to the 24th. But would we type that in as our answer? No. Jimmy, can your little calculator compute what our answer is? Did we all get that answer? Yes? Does that make sense? Okay. Just going to keep making it harder then. Okay. Number 3, parentheses, -2 x y to the third z to the fifth, close your parentheses, to the sixth. I'm just writing it really big so that you can see it and my marker doesn't smush. Can you tell me the simplified answer? It'll just say simplify each expression. That's literally all the instructions will say. Brain, you have an answer you want to share? Okay. Did we all get the same answer? No? What's wrong? No. Did you not type the negative? So here things are either one of two things. You need to type the number and the negative in parentheses when you take the power, or you just need to know that when the power is even, the answer is positive. The power is odd, the answer is negative when it starts out negative. When it's even and odd and the answer is already positive, it just stays positive. Okay? Remy, you ready to give you one that like mixes most of them together? Okay, I can fit this up for here. Bracket, parentheses, 8g to the third, h to the fourth, parentheses, squared, bracket, squared, that's only half the problem, times, I don't know why, but I used a bracket, 2g h to the fifth, close your bracket, to the fourth. That's your problem, though it gets bigger as I go on for some reason. I would simplify one piece at a time. You cannot deal with that multiplication in the middle until you are done simplifying your powers. Try her out. See if you get it. I don't know why my 3 is so lower than everything else, but it's there. How did we do? Easy? Not easy? Awesome. Awesome sauce. That meant waking up your brain. Multiplication of properties, pretty easy. Okay, ready to learn your division properties? Brain, you're not ready? Why not? No. We can't learn them tomorrow. We have a limited schedule before your state test. Got no time for that. Cool, that's wrong. Oh, did you count? Oh, did you count the weekends? Oh, yeah. I was counting school days. Okay. I'll put the title in black. It'd be fine. Okay. 7.2 is division properties of exponents. Division properties of exponents. There's 4 of these. And realistically, only 2 of them you learned in the last one. So, easy. Huh? Yeah. Of course we are. The first one is called a quotient, right, which is just a fancy word for division, of powers. Quotient of powers. AKA if we have things in a fraction. So we're going to put a to the m power on top and a to the p power on the bottom. Take a hard guess. Shouldn't be hard. When we multiplied numbers, we added them together as exponents. When we divide numbers, what do you think we're going to do with their exponents? Subtract. I'm losing your mind. When you subtract, this is literally hit or miss. It's up to you. Always do the largest number minus the smallest number. So that's the only biggest thing. So largest minus smallest. It's not top then bottom. It's largest minus smallest. So right now we're going to do a to the m minus p. But really largest minus smallest. Yes, you never want a negative exponent. And then you put your answer where the largest was. So if it was on top, you put it on top. If it was on the bottom, you put it on the bottom. Because you are correct. We are not allowed to have negative exponents, which is one of our rules. Okay, so this one we kind of already knew, other than the largest minus smallest part. The next one, you already know, we're just putting a fraction in it. This one is called power of a quotient. So again, we're going to have the parentheses. It's going to be a divided by b. That's our fraction. All to the p power. Why not? I pick whatever variable I want. Again, when you have something on the outside, it goes to everything on the inside. So that includes top and bottom of the fraction. So a to the p power now, because it's p times 1, and then b to the p power. So that's just reminding you that you have to do it top and bottom. See, you basically already learned those ones. The best one and the easiest one, which always tricks people because they think it's so easy. This one's called the zero exponent property. It says that anything, we're going to say A, to the zero power, anything to the zero power will always equal the same answer. One. Anything to the zero power is always one. If you don't believe me, you could try it with any number right now in your calculator. I promise you, it works. Anything to the zero power is one, unless your brain, you're trying to use your elbows. It's still zero. It's still one. Well, that's because you can't use zero. Zero is not considered a number, it's a neutral number. Yep. No. You have to put -1 in parentheses to the zero power. That's why. Because you're only taking the zero power of that number, not the negative sign. No, you can't have negative nothing. No, you can't. You can have negative of when you count something, but you can't count something that's not there. You can't have negative it. Yes, silly boy. Okay, last one. Negative. This is the rule Ty talked about. Exponent property. I give it to you last because it's always the last thing you check. You always make sure you have no negatives and you work on it at the end. It's your final touch. Anytime you have a negative, so if I have a to the negative n power and it's a whole number slash it's on top of a fraction. Technically, it's a whole number. I'm drawing it as a fraction to help you out. The way you get rid of a negative exponent is to help it cross over to the other side. This is like the most cryptic thing I probably say all year. Okay? So think about this way. When you die, there you go. I'm being real sad about it. When you die, when you cross over to the other side, things are, we always paint this image of things being happy and pearly gates, right? It's all happiness is going on. So when you cross over to the other side, everything's positive and happy. So if this is our exponent is negative, if we cross it over the line to the other side, you make just the exponent positive. The number does not change. Whatever it's attached to does not change except for its exponent. So if it's on the top, it moves to the bottom. Vice versa. If it's on the bottom, it moves to the top. This one I'm going to give you an example for because people mess this up all the time. So if I have 4 over a to the negative third, that's my original problem. 4 divided by a to the negative third. We are not allowed to have negative exponents. It's against the law of mathematics. Okay? Well, we need to cross a to the other side. So this is the only thing that changes, the thing that's negative. So we're going to cross him over. I always circle it and draw a line. 4, you leave him alone. You move a so he's nice and happy. Technically now my denominator's 1. Huh? If it's on the bottom, you move it to the top. If it's on the top, you move it to the bottom. Because the 4 did not have a negative exponent, so it does not move. You only move the thing that had the negative exponent. That's the thing people mess up all the time. You only move that thing that has the negative exponent, whether it's a number or a variable. So we are going to practice these because this is the one people mess up. This, and they forget to distribute all their powers to everything on the bottom. And then what's going to happen eventually is they're going to mix 7.1 and 7.2 together with their powers and topics. Okay. So let's start off semi-easy. Fraction, because this is, the division section. We have x to the third on top, y to the fourth on top. On the bottom, we have x to the second power and y to the sixth power. So write it down. Well, again, the instructions will just say simplify. So every time you do this, I look and go, are there more than one x's in multiple places? So look at one at a time. Here are my x's. There's a 3 there and a 2 there. Which one's bigger, 3 or 2? Take the bigger number and subtract the smaller number. What's left over? 1. Where was my bigger number at? The top of the fraction or the bottom? So that's where my answer is going to go. So I'm going to draw a fraction line. I always do it for all my answers, and I'm going to write x to the first. Do I have to write to the first? No, you can just write x, right? But if it makes you feel some kind of weird comfort, you can put to the first. Now we're going to deal with the y's. These are my y's. Which one's bigger? Subtract it. What's left over? Where's my y to the 2 going to go? So I'm going to write y squared on the bottom. I double check when I'm done. Do I only have one of each kind of variable? Do I have any negative exponents? Good, done. I think that's just equally as annoying as the D word. You making that noise. Might be eventually. Okay. Parentheses. Fraction inside your parentheses. 3. P to the third, all on top. 7 on the bottom. Close your parentheses. All of it squared. You got too close. What are we going to do? Put that 2 with all the other power spots. Not with whole numbers, with the power spots. Remember, you're not multiplying the whole numbers, you're multiplying the exponents. So 3 turns into 3 squared. P turns into P to the, yeah. And 7 turns into 7 squared. And then obviously you should actually write what those numbers are. So 3 squared is P to the 6 is P to the 6. What's 7 squared? 49. A good hint is, you're like, 9 over 49. I wonder if I can simplify that. Here's a good hint. You can't. Miss Renati, how do you know you can't do that? The original fraction. Could you simplify the original fraction? 3 over 7? Then you can't simplify the final answer. Now, if the original fraction can be simplified, simplify it first. Makes your life easier because you do have to type in the simplified answer. Okay, so why make the extra effort? I'm only doing one property at a time right now. Okay. Here, let's mix 2 together now. Because I can't really do any more without, oh, I can, right. N to the negative 5th, P to the 4th, all divided by R to the negative 2nd. There's no like variables, so the only thing to do is Simplify it so there's no negatives. What I do is I circle only the thing that's negative, draw where it's going. Circle only the thing that's negative, draw where it's going. You should put your variables in alphabetical order if they're on the same line. So if you're saying the alphabet to yourself right now, I'm sorry about your life. So we only moved the ones that were negative. You see how we left P alone? But we did scoot him over because now he's in front instead of in the back. Because he comes before R in the alphabet last time I checked. No, Ty was singing it earlier, so who knows? I'm going to mix them now. Okay. Fraction. On top, 5 R to the negative 3 T to the 4th. Bottom, negative 20, that's a whole number, remember? R to the 2nd, T to the 7th, U to the negative 5th. What are you gonna do first? No. Simplify the fraction first. I would always simplify 5 over negative 20. Can you simplify 5 over negative 20? Yes. What does that turn into? Huh? Okay, so 1/4. I can keep the negative on the bottom if I want. I can put it on top. It really does not matter. Now, all I'm doing is one thing at a time. Now, do I have, you leave the negatives for last, okay? So now, next thing to the next to the 5 is the R's. Are there multiple R's? Which one is greater? What happens when you do 2 minus negative 3? You get 5. Where's my final answer going to go? On the bottom. So when I combine my R's, didn't I also get rid of a negative? See, that's why we don't move. You're wasting so much time if you move your negatives around first. T's. Multiple T's. Subtract biggest minus small. What do I get and where does it go? 3 on the bottom. T to the 3rd. Do I have anything left over? U to the negative 5th. Do I only have one of them? Now this Ty, what am I going to do to it? He is going to become positive and cross over to the other side. So he is now U to the 5th, lonely by himself, really, with that 1, but we don't usually write 1s, right? So he doesn't really mean anything. So really, if we were going to type this into Alex, if I just erase that with a little saliva, there you go. That would be your answer you would type in. You wouldn't need the 1 because you don't need it, right? It's just the number 1, Ty. But you don't need it because the 4 is on the bottom. 4 being on the bottom shows you that it's a 1/4, you silly Billy. Okay, try another. 5. Fraction again. How about V to the negative 3rd, W, X squared. That's on top. That is not well done. On the bottom, W, Y to the negative 6th. Will you simplify this problem for me? Remember, you should do simplify, combine like terms, move my negatives. That should be your order. Well, simplify doesn't do dividing and then also degrees. Somebody's getting yelled at outside. Donovan, did you put that sticker on that red sheet I gave you? Another thing you can do is just do one variable at a time. But if you do your variables, do them alphabetically. Mr. Ty Little. Okay. You're just lucky they were in alphabetical order for the most part. Technically, Y is not in any order because, you know, technically X is in a different order than Y is. What? Poor W's, they cancel each other out. We just had to move your negatives around. You ready for this big scary one? Good, I'm glad. Parentheses. Fraction within your parentheses. Top of the brackets. Fraction. 2f to the 4th, g to the 7th, h to the 3rd. Bottom, 15. F to the 3rd, G to the 9th, H to the 60th. Close your parentheses. How you doing, Ty? Good. How you doing over there, Isaiah? Did you do this problem yet? Please look at the problem, please. Lila, what's the answer? My favorite part's when someone, it's usually Ty, it's a kid like Ty every year that complains the whole time I write the whole thing down. Yeah, we were like, oh my gosh, F and G and H, you just kept complaining. Yeah. Okay, let's have a real one. Okay. Top of the fraction. B to the 4th, C squared, D to the 0, B squared on the bottom, C on the bottom. Only the denominator is in parentheses. This happens sometimes. And then square just the bottom. So parentheses around just square just around the parentheses. It is a 0, just the marker doesn't do so well with the zeros. But only the D has the 0, so there is work to do here. Order does matter. It's still a funny answer. I just made it up, by the way, too. What are you talking about? I did it. I just did it. It just worked out really well. Mathematically, what do you have to do first? Huh? You have to distribute the bottom. You have to put the 2 with the 2 and the 2 with the 1. Then what do you do next? Technically. We're combining like terms next, yes? What happens? I made that one up. That was pure coincidence, actually. Okay, let's be surreal, for real. Last one. Make it a good one. Parentheses. Fraction. Top of the fraction is 5. J to the negative third. K squared. M to the negative sixth. Bottom 25. K to the negative fourth. M to the negative second. Close your parentheses. Ready? All of it to the negative second power. This is a legit one. What do you think is the best course of action when the big number on the outside is negative? True. So that could save us a lot of time, couldn't it? Yeah. Good. So you just distribute, don't you? But there's a problem. Can you type in 5 to the negative second power? You can't, can you? Because you're not allowed to have negative exponents, are you? Huh? No, because the exponent's negative, not the 5. You want to know the real problem? When there's a negative out here, what do we do with negatives? We cross them over to the other side, don't we? When there's a negative out here, this fraction, you got to be flip-flopped. You have to flip the whole thing. Just the top becomes the bottom becomes the top. So you never distribute the negative, you flip the whole thing. Keep the exponents exactly as they are and flip the fraction. You keep the 2 there, the negative is gone. I do it one step. I square them. I distribute the squared and flip at the same time, but maybe for now, maybe just one thing at a time. So that negative sign really means flip the whole thing. Then you distribute, then you can keep doing on with your life. Technically, you could distribute and then flip. You could distribute it all, and then you end up only flipping some of the numbers, so when you subtract it, you should get the same answer. I guess it doesn't matter. Let's mathematically see if it matters. Let's do the math. What? So a lot of going on out there. That's a 3. Okay. Oh, it does not matter. I did it both ways. That's nice. I didn't finish the math on that. I used the bottom of this. I can't zoom out, I don't think. There it is. I used the bottom right here in the black. And I distributed the -2 and then did all my math. You have to switch the numbers because they're negative, so you can't apply them. But I did all the numbers the same. You still get the same answer. So whether you flip first or flip at the end, you'll still get the same answer. I thought it would work, but I always just flip it first. Because most of the time, all your exponents aren't negative on inside, so it really just stops you from having all these extra negatives. This one, I just challenged you extra and gave you a lot of negatives. So if the negative exponent power confuses you, leave the negative, distribute it, but leave the whole numbers for last. Like do all the variables, and then I just flip the whole numbers because you won't be able to do those until the exponents are negative. So I flipped them. Then I could do 625 over 25, which is really just 25. And then look, all the variables are exactly the same. 625 is 25 squared, so it does not matter. Which is perfect. Make sure you pay attention to the powers of 0 because it will just catch you off guard. You're in a rhythm and then you will just be forgetting what you're doing. But yeah, you learned 7 properties today. That is all. If I can find my mouse. There she is. That's it.